Welcome to a session on waves, and here we'll be discussing waves, what are waves, how are waves caused, types of waves, and speed of waves. So, I hope you have covered the previous sessions on KTG and SHM, specifically all of them, right? Moving on, let us begin. Now, I had mentioned what are waves. Now, you know the theoretical definition, right? But what we need to understand is wave originates from a vibrating body. Now, if there is a particle and say it vibrates, so what happens is if it is in a medium, in a mechanical medium, the medium close to it also vibrates, and again the subsequent particles also vibrate, and that way the vibration spreads out, right? So simply putting, the definition of wave has been mentioned, but just in case, a wave is a disturbance caused due to vibrations, okay, or wave is a result of oscillatory motion of a system, and that oscillation carries some energy, and that wave in essence carries some energy along a given direction or along the direction in which it propagates. The theoretical definition you know better than me, right? So let's not worry about it. Now, wave motion, you know that it causes movement of energy or momentum along a given direction without actual movement of particles or without actual displacement of particles, right? Since the medium is oscillating, the particles are supposed to go from their position and again come back to their position. So they're not being transferred from one position to another, but rather they're in a state of oscillation. This definition I personally find to be a better one. A wave refers to energy or momentum being transferred without permanent displacement of particles from their main position. We'll know more. So now waves can be of multiple types. They can be mechanical waves, they can be electromagnetic waves, and they can be matter waves, right? Now we people are normally going to be focusing on this first part, mechanical waves. Now mechanical waves, the definition has been provided in the previous page itself. What is important is that they require a medium for propagation. Now there is a surface of water, say, okay, there is a pond, and you throw a rock towards the center. Now then there are ripples that spread about from that position. Now imagine if there was no water, if there was no transfer of energy from that point, would there be any ripples? The simple answer is no. So waves are mechanical. The mechanical waves, they require a medium for propagation. That medium should have particles. The particles need to vibrate or oscillate about their position and result in transmission of energy. Second category, EM waves, we have already discussed. Now what happens is, whenever we are talking about a, say, let us have a three-dimensional plane. Whenever there is a electric field, it results in a magnetic field along its perpendicular direction. Okay, so here the magnetic field is being represented on the xy plane and the electric field is being represented on the xz plane. So electromagnetic waves are self-propagating waves that are a resultant of electric and magnetic fields which vary with time and result in the formation of each other. Like an electric wave can result, or an electric field can result in a perpendicular magnetic field, and a magnetic field can result in a perpendicular electric field. Now they travel with a very high velocity. Their velocity is equivalent to the velocity of light, that is c equals to 3 into 10 to the power 8 meters per second, and they do not need the material medium to travel. They do not need air to travel, they do not need water to travel. They can travel through space without the support of any material medium, because you see, they are not movement of particles but rather they are movement of fields. A field changes with time, that results in formation of another field, and hence they do not need a medium to travel. Next part is matter waves. Now matter waves refer to basically the waves that are a result of the behavior or the wave behavior of high speed particles. Okay, you have got the de Broglie wavelength, lambda equals to h by p, Planck's constant. We will be covering it in later chapters, but just know they are not your conventional waves per se, and also they do not need a medium like air or water to travel. If any of you pursue quantum physics or have a paper related to it at a later point, you will know, and it is also present in your second year syllabus. Now, waves or mechanical waves, here waves can be of two kinds: transverse waves and longitudinal waves, right? So one case is motion of a particle being perpendicular to wave's direction. Now this direction that you see here is the direction along which energy is being transmitted. If somebody says you direction of wave, that basically means direction of energy transmission. So there are transverse waves and there are longitudinal waves. In transverse waves, the motion of particles of the medium are perpendicular to the direction of propagation of energy. So whenever you're talking about, say, ripples on a water surface, the energy might be moving forward and the particles are moving up and down. And second case is longitudinal waves. Longitudinal waves, basically whenever you're talking about sound, a sound can be said to be a series of, say, compressions and rarefactions. Again, compressions and rarefactions. So at one point, at the point of compression, we have a region where the particles of the medium are pretty close together. Okay, so this is a high pressure region, and then we have got a section of the medium which is having the particles that are spread out. So that is low pressure region. The high pressure region is known as compression and the low pressure region is known as rarefaction. Alright, So there are certain requirements for a medium to be able to transmit waves. First is the medium needs to be elastic and the medium needs to be inertial in nature. Now tell me, why elastic? What if the medium is not elastic? Now, just as we had discussed, the particles need not be actually displaced from their position, but rather they need to come back to their original position. Now, if they do not come back to their original position, they cannot sustain a wave. There should be a restoring force. A particle is displaced from this position to this position and it needs to come back to this position. There should be a restoring force. Now, if you're talking about a restoring force, elastic bodies have a greater restoring force. What is elasticity? It's a measure of the tendency of a body to come back to its original shape after being deformed, or the tendency of the particles of medium to come back to their original position after being temporarily displaced, right? And the next part is inertial. Now, why inertial? We had discussed in SHM regarding the kinetic energy to potential energy conversion and vice versa in case of a wave. Okay, please go through the part in SHM where it is discussed that the kinetic energy and potential energy need to be balanced out, right? There is a mean position. The mean position is the position of highest kinetic energy, and then there is the extreme position, which is a position of highest potential energy, and all of the potential energy needs to be converted to kinetic energy and vice versa for the oscillation to sustain. So if the medium does not have any inertia, then it will not have a tendency to oscillate. So again, no oscillation, no wave. Let us proceed to the second part. Transverse waves, right? Now here we are dealing with the speed, the transverse wave. Now let this be empirical, right? It will be simpler. So speed depends on two factors here. One is tension and the other is mass per unit length. Now it is mentioned root over of 1 by ml very directly, but in simple terms we can say that V is proportional to tension and then V is also proportional to mass per unit length. Now in this case we do not actually know how it is related, or the powers, the exponents which relate it. Okay, so you know dimensional analysis better than I do, right? I'm sure you do. So for the dimension of velocity we have L1 T minus 1. For the dimension of mass per unit length we have M1 L minus 1, and for the case of tension, which can be considered equivalent to force, we have M1 L1 T minus 2, right? So equating all of these things, we have got, say, T to the power X and ml to the power Y. So we have velocity proportional to T to the power X and ml to the power Y. Now let us equate the powers of M, L and T from the LHS to RHS, right? So in the RHS what we have? M to the power X plus Y, and here we have M to the power 0. Then we also have T to the power minus 2X equals to T to the power minus 1. So when we equate the powers, minus 1 equals to minus 2X, or X equals to half. This thing, when we use with the known condition that M to the power X plus Y equals to M to the power 0, so x plus y turns out to be 0, or y equals to 0 minus 1 by 2, right? So that is y equals to minus 1 by 2. So that's pretty much simple. Now similarly, let us proceed to the next part, where we have the longitudinal waves and their speed. Now again, I'm directly mentioning the factors that affect the velocity of longitudinal waves. Now velocity of longitudinal waves is affected by k, that is the bulk modulus. You know this, volumetric stress by volumetric strain, and the density of fluid, right? So if the dimensions of bulk modulus are found to be m l minus 1 t minus 2, and the dimension of density is m l minus 3, and again we have bulk modulus to the power of x and rho to the power of y. Let us multiply the dimensions, and what we have is the dimension of velocity is m naught l1 t minus 1, and the dimension of the RHS, the multiplied result, is mx plus y, l to the power of minus x minus 3y, and t to the power of minus 2x. So we can basically obtain three expressions from here, equating the powers. X plus y equals to 0, that is the first part. Minus x minus 3y equals to 1, second part. Minus 2x equals to minus 1, that is the third part. So this is basically a no-brainer, right? X equals to minus 1 by minus 2, so x equals to 1 by 2. Now you have found that x is equals to 1 by 2 and x plus y equals to 0, so y equals to minus 1 by 2. What does that basically mean? That means what you have is VL proportional to k to the power 1 by 2 and rho to the power minus 1 by 2, or VL proportional to root over of k by rho. Okay, so this is another one. There must be certain factors, as you just discussed, that affect the speed of waves. So let us take a short look at those factors. Pressure can affect speed, density can affect speed, humidity can affect speed, and temperature can also affect speed. Okay, how does pressure affect speed? Now just note it down for right now. Velocity is equals to root over of p by rho. Okay, now the important aspect here is that when you increase pressure on something, say you're increasing the pressure, and basically on a gaseous medium, on a region of gaseous medium or on a region of fluidic medium, so increasing its pressure can result in it being compressed and an increase in density. So whenever you increase pressure, the density increases, so del V, or change in speed, equals to 0. So V remains constant. Okay, then you know ideal gas equation, PV equals to nRT. Okay, so you find the value of P, pressure. Okay, so we have got 1 by V, Now n can be mentioned as w by m. How? That is, if w is the given weight of something, right, and m is the, or say w is the given mass, m is the molar mass, then that will mean number of moles equals to given mass by molar mass. That is what we have done here. Okay, given mass by molar mass into RT. So what you can have is given total mass by volume is density, and बचा क्या, RT by M. So rho RT by M. ठीक. So that means when velocity needs to be increased and you feel like, okay, let us increase pressure and the velocity will increase, that case is wrong. Okay, this equation here shows that pressure increases, density increases in direct proportion. प्रेशर जितना बढ़ा डेंसिटी भी उतना ही बढ़ेगा. Now from here we know that velocity is directly proportional to root over of pressure and inversely proportional to root over of density. So let us go with this part. Now pressure increase करके density increase हो जाता है, ठीक है. But can we increase the density without increasing the pressure? Yes, we can. So that means velocity is proportional to root over of 1 by density. So it means pressure बढ़ने पे velocity नहीं बढ़ेगा, but density बढ़ने पे velocity घटेगा. डिटेल में दिया है, अगर डेंसिटी बढ़ गया, डेंसिटी का स्क्वायर रूट विल ऑल्सो इंक्रीज. सो व्हेन द डिनोमिनेटर वैल्यू इंक्रीजेस, ये 1 बाई डिनोमिनेटर डिक्रीजेस, सो वेलोसिटी विल डिक्रीज. सो डेंसिटी इंक्रीजेस, वेलोसिटी डिक्रीजेस. दिस इज हाउ डेंसिटी अफेक्ट्स वेलोसिटी. प्रेशर इंक्रीजेस, velocity constant. Okay, so pressure does not affect velocity. Density increases, velocity decreases. Now whenever we are discussing the effect of humidity on velocity of sound, we need to keep in mind that velocity of sound in solid is greater than velocity of sound in liquid, and that is greater than velocity of sound in gas. Okay, it is again based on the same formula. Just the one part that we need to keep in mind is water vapor has a density of 0.8 kilograms per meter cube, whereas dry air has a density of 1.293 kilograms per meter cube. So what does that basically mean? Rho for dry air is greater than 1.293. So if rho for dry air is greater, then velocity in dry air will be smaller. So this is very much apt as mentioned here. Okay, so velocity of a mechanical wave in a region of higher humidity is greater than that of a region with lower humidity, in theory. Now the next part is temperature. This is a very simple concept. You had come across this term PV equals to nRT So that means if V was mentioned to be directly proportional to root over of P, that means V is directly proportional to root over of RT by M, or V is directly proportional to square root of temperature. If temperature increases, then velocity of sound also increases. So that means pressure increases, velocity of sound not affected. Density increases, velocity of sound decreases. So velocity of sound in humid air is greater than velocity of sound in dry air, and temperature increases, velocity of sound increases. That will be it for this lecture. Alright. Best of luck for tomorrow's exam. And I also need you to keep track of a certain few number of topics, that is interference, constructive, destructive, nodes, antinodes, I guess velocity of sound. I think that should be it. That covers most parts. And SHM also, I guess you have covered it so far. Center of mass, again, done. And do well. That's all I got to say.